I'm Eugenio Grosso from Pure Storage. I'm a principal solution architect with a specific attitude to work on virtualization and cloud at Pure. Today I'm here to introduce you to a concept that is of course related to storage. And if you are here, probably you are interested in hearing something in that direction. What we have in the storage, not only in the VMware environment, but generally in every kind of environment, is the elephant in the room. It is the fact that till today, access to storage is mediated by a single protocol, SCSI. And the SCSI then is, of course, tied at the top the carrying protocols like Fiber Channel and iSCSI for the Ethernet. And it is literally the elephant in the room because everything that goes down to the storage is blocked by the fact that the SCSI protocol was designed for spinning disks and not for today's storage, which is mainly flash-based storage. The new protocol that was raised almost 5 years ago and to the scene is indeed NVMe, which is instead designed to give more performance, to bring all the performance that is available for today's storage, for modern storage, into the application level, not only to the using host, but up to the CPU and made available directly to the application. The way SCSI was created, as I said before, was with the concept of letting application access the spinning disk, and yes, of course, those limitations, the limited queue depth, the limited throughput, and that was designed indeed for the spinning media. So all the I/O, it's the limitation of that protocol, the fact there is a single point of access, the fact that everything has to be queued along that access path before reaching up to the applications. While with NVMe, NVMe, not only NVMe Over Fabric, but NVMe per se, was instead designed with the flash devices in mind. So parallel access, the most high throughput available for those devices must be used by the end user application, by everything, every workloads that have the storage. So there is high parallelism implemented. There are parallel ports, and not only there are more ports, but they are wider than what you can get from the single buffer that you have in the iSCSI protocol. So the final result is that there are increased queue depths. The throughput is the maximum available provided by the flash media and the carrier, and the design was specifically made for flash technologies. The good thing is that this can be implemented end-to-end, so you can get direct access from the CPU down to the flash memory through the protocol, and the protocol can be easily implemented and ported on the fabric. So NVMe Over Fabric, which is the extension of the standard NVMe that you can get on each single device, the phones, our mobile phones, they get access to the flash memory straight by NVMe. That can be extended easily to the fabric with a negligible impact on the infrastructure. In theory, there is no purchase necessary for transitioning to the old SCSI access model to the new NVMe Over Fabric technology within an existing fabric in the infrastructure. That's partially true, because it depends mainly on the level of improvement that you want to get from the underneath infrastructure. The transport media that you can get for NVMe are, of course, still based on the fact that you can have a fiber channel network in your infrastructure or a TCP based, an Ethernet, if you will, based fabric in your infrastructure. So for fiber channel, you need specific HBAs and switches that can support NVMe. For the fabric configuration, that's the same thing that you get as today for the SCSI. You had to apply zoning on the switches. And specifically for vSphere support, you need to be on vSphere 7 update 1 or later. If you're on TCP, the good news is that there is probably nothing changed apart from the fact you need to be on vSphere 7. So vSphere 8, which is, in my opinion, and to what I can see in our customer estate, is that almost them have already transitioned to vSphere 8, which has everything implemented internally for supporting NVMe over Fabric. So you get the same drivers that you can get for fiber channel, those that are specific for the HBA and those that are specific for iSCSI, whether it is the virtual driver or is the physical driver provided by the SCSI vendor. Then you have the same for NVMe over Fabric. So everything is implemented nowadays into your vSphere environment. If it is on version 8, if it is on 7, you have those two caveats that you have to respect. Which kind of transport to choose? It depends on the mainly on performance. So if it is you can span from the lowest performance through starting from TCP, or if you want to reach up to the maximum performance, you have to go to RoCE. RoCE requires specific hardware for being putting in place. So you need NICs that are capable of handling RoCE directly, but they give the maximum performance. The latency that you can imagine can go across this sort of diagram is something that goes up to or down, if you will, 100 microseconds for RoCE, and up to 500 microseconds for NVMe over TCP. So across that line, it depends whatever kind of performance you want your application respect, and then you have to invest accordingly to get the maximum, the minimum latency and the maximum throughput available. In between the two lies the fiber channel protocol that, again, doesn't require too much effort for being implemented and provides a mid-range gain with respect to what you can get between TCP and RoCE. The easiest way, of course, is to go for TCP, which doesn't entail any specific effort. You can start with 25 gigabyte, even for a test environment, for a trial with the 10 gigabit network cards, and get NVMe over Fabric straight implemented in that. And of course, the easiest of implementation goes the opposite way. RoCE is the hardest to implement. Is the easiest to implement. The TCP is the hardest, but you can have a mix of the. You can choose whatever fits your needs in terms of performance, ranging between the three kind of different implementation. And of course, if you have an already existing fiber channel fabric that you don't want to replace and you are not planning to replace, probably the easiest way is to go for TCP. Is to stay there. If you are planning to renew your infrastructure for a more modern and, if you will, also agile network, and unify everything on TCP. On Ethernet, probably the right choice is TCP. Use cases. In practice, there is not a specific use case. I would say that in the vast majority of the cases I've seen, databases optimization is the most widely used case there is nowadays. But everything benefits from NVMe over Fabric. specifically machine learning AI application, they can get the maximum throughput. Same is for analytics. Everything that has to deal with the, large data that requires high throughput and low latency benefits from NVMe over Fabric. And in the end, it has to be a transition then that in a time span of 5 to 10 years has to be adopted, because it is the only technology that guarantees the end-to-end accessibility of the data with the minimum impact on the infrastructure. So basically, you can handle everything that every workload. You can have the benefits of NVMe. And as I said before, you can start easily if you have a nice casss network and you want to transition to NVMe, leveraging NVMe over TCP. What changes in terms of vSphere? As I said before, there are very few changes, because all what you need is already available in vSphere 8. The approach is the same as you have today for standard HBAs or iSCSI fiber channel HBAs or iSCSI FBAs. The differences, the main differences are listed here. There is the fact that you are not dealing anymore with the WWQN, WWPN, but there is the analogous for NVMe over Fabric, because the protocol has been, of course, defined and then implemented with trying to cover as much as possible the same features that were in for the configuration standpoint that were made, that were decided, designed for the SCSI protocol. There is the namespace, which is a little different concept with respect to the SCSI. It is essentially a volume that it is the way the volumes or the LUNs, if you will, are presented in the old naming, are presented to the consuming hosts. Then you have the controller. The controller is the target. It could be thought as the former iSCSI or fiber channel target. In our case, they are able to manage the endpoint, in which in our case is the flash array, and is the way the ESXi hosts they talk to the target that provides the volumes. And then there is the NVMe adapter, which is the host bus adapter that you find in your vSphere environment. And is the actual endpoint or initiator, the physical initiator or virtual initiator you have in ESXi for communicating with the target controller host. The high performance plugin is the implementation of the internal load balancing mechanism across the path. It's the here you see what are the type of path selection mechanisms that are implemented for the load balancer that spreads the load across the different network paths. By default, the plugin that is used is the fixed plugin. So there is no detection of what is the fastest path through the or the less used path to the target array, which is the one that is used by default in any context where you don't know exactly what would be the best algorithm to be configured for the endpoint. The load balancer Robin sets the connection to the first path and then scrolls across all the paths trying to find out what is the best one. Then it sends packets up to a certain size to the first path, then it routes to the second and then the third, and it goes this way across all the paths, load balancing in round robin fashion. The the IOPS load balancer sends out packets to the first path, then to the second, to the third, and determines what is the one that has that can provide the highest IOPS throughput, and then uses that path until it becomes more clogged than the others and switch over and the second one. Same thing happens for the load balance bytes. It uses instead the queue. It doesn't count on the IOPS, but on the queue depth for each single path. But the way they work is always the same. They try to detect the fastest path in terms of number of bytes that can be sent out in a unit frame, or the number of IOPS that can be expressed in a unit frame, in a given unit frame. All those things are configurable, like it is, for instance, for the latency. So this is very similar to the multipath handler that you have today for SCSI, both for a fiber channel and iSCSI protocol in ESXi. From the networking standpoint, it's very similar to iSCSI. So it's for NVMe over TCP. Very few changes. So the configuration of the network is the same. You have to provide two switches for redundancy. You connect your targets to the switch in a crossed fashion, and it's a very similar configuration with respect to iSCSI. The only thing that changes are the virtual HBAs. That's it. You configure, instead than deploying your iSCSI virtual adapter, you configure your NVMe virtual adapter. For the fiber channel, again, no big changes with respect to the existing infrastructure. It is the switches that they have to be properly supporting NVMe over Fabric, over TCP. The configuration is very similar to what you configure today for the fiber channel. You go straight down on your ESXi configuration, host by host, and you configure the WWN and the WWPN on the HBA on the configuration section, and that's it. Like this today for fiber channel. And then you provision your data store. Features that are unsupported in vSphere 7, that's the list. You don't have a possibility to provide raw device mapping. Unfortunately, even virtual volumes are not supported, so you don't have any chance to leverage vSphere 7 for efficiently provide storage on VME for databases. RDM and vVols are probably the major feature that you want to use for databases. Xcopy as well is not supported. VMSC is not supported as well. Boot for some, there are a lot of limitations for, so if you are on vSphere 7, you can just leverage the VMFS data stores for their provided feature, and that's it. For vSphere 8, we have instead almost all the features supported, but the vSphere Metro cluster. So VMSC is the only thing that is not supported today. Virtual volumes are fully supported. Shared VMDKs are fully supported. You can boot from SAN as well for fiber channel. And you can use end-to-end NVMe, which means that the CPU is able to actually access each single memory cell in the flash, in all the flash array directly. For instance, we at Pure provided the first end-to-end implementation of NVMe over Fabric, and our modules, they don't have the old SCSI layer, which is implemented instead in the standard flash modules. and you get end-to-end access from the CPU down to the memory cells that resides in the flash array. Something completely different now, of course, we, as Pure, we have our own implementation of NVMe for the appliances in general, and specifically for VMware, what we have, we complement the environment with our plugin. The plugin is able to automatically configure almost all the features that you want to get from NVMe, which means that you have access to the storage mediated by the plugin. You don't have to go to the appliance to configure anything. The appliance appears, all the appliances that we attach to a VMware environment can be driven by the VMware UI to the standard implementation of a plugin, which since version 7 of vSphere requires a specific appliance. So we have a vSphere client and a VMware analytics collector that are all provided by the appliance that can be installed on vSphere, providing a plugin that works like any third-party plugin. So here there's the is not rendering the images properly. But essentially, what you can do through the plugin, you can configure your endpoints, your storage endpoints. You can provision and manage the data stores right from the plugin. You don't need, as I said before, to go through the array for configuring anything that is related to your consuming environment. You can monitor everything from the same pane of glass as you are used to. So through your vSphere environment, your vSphere console, you can monitor everything from what concerns also the array side, and you can manage the data stores through the plugin, as well as you can protect your applications whenever the volume type that is used are vVols, in the same way as you will do through Site Recovery Manager, without having the needs to recur to Site Recovery Manager. That's in a certain sense given by the fact that the virtual volumes were designed since the beginning by VMware with that in mind. So you don't need, you can do automatic failover of the virtual volumes through the virtual volume API framework, and we leverage that into our plugin for not requiring the utilization of Site Recovery Manager for implementing disaster recovery scenarios. And that's the reason why the usage of a Pure Storage plugin, whenever there is a fleet of flash arrays storage provided by Pure, those are the reasons why the usage of the plugin simplifies the overall management of the whole life cycle of the storage in a vSphere environment. Plus, there is the possibility of integrating with the monitoring console. Even here, it doesn't show the picture very well, but this is a very powerful tool that is unique to Pure, and this one is integrated into our plugin and provides the full view of the analytics that you can perform for every IO operation across your vSphere platform. It gives you the full track of what's happening to the I/O from each single ES6 host you have in the environment down to the array. So starting from the VMs down to the array, you have a drill down of each single segment that the I/O chain goes through, and you can easily identify where are the bottlenecks on whether they are on the virtual machine or they could be on the vSphere layer or down to the fabric till the array. So you can identify with this tool exactly where the bottleneck in your infrastructure or still even in the application resides. This gives you the possibility of controlling the entire environment and reduce and eliminate possibly the bottlenecks and identify issues in your storage chain before or immediately after they show up. Things like the noisy neighbor VM, those are very easily spotted using this kind of tool, which is again unique in the paramount of tools that are available on the market from any other storage vendor. And that's it for this short introduction to NVMe Over Fabric. So if you have a question, please don't be shy and no, for the VM standpoint, there's nothing that impacts the VM. They can see whether, of course, we pioneered, for instance, in the landscape of the vVols. So but for the VM standpoint, you still see the data store. You can, whether it is VMFS data store or a vVol data store, as presented as is today with the SCSI. So the difference is that the media that transport the data across the fabric down to the cell benefit from the fact the protocol that carries the data is optimized for directly accessing the cells, the memory cells in the flash system. So the NVMe protocol has been designed for giving the maximum throughput with the lowest latency in terms of accessing flash memory cells. The NVMe Over Fabric brings this up to the fabric level and lets the CPU leverage the same protocol as they do today with the internal connected NVMe disks. So there is no impact for the VM, because the VM in the end, as always, is a process that runs on top of the hypervisor. It is the hypervisor that gets the maximum throughput from the network and from the SAN for accessing the data. No. Yes, correct. Yes. Yeah, and if you, for instance, decide to utilize vVols, then you get also the maximum flexibility, because your virtual disk at that point is not anymore a VMDK landing on a file system, but goes straight down to the volume as it is implemented by the single storage vendor. So every vendor that provides the vVol implementation, they can provide literally end-to-end connection for their disks using NVMe. It is like, in that case, it is like having a bare metal machine that connects straight to its NVMe SSD. Same thing.